Our last example is a real-world example where we use a graph of a quadratic function to solve a real-world problem. Now, before we get into the problem, I have a nice little tip over here that I want to talk about, where it says only 3 to 4% of high school football players get the opportunity to play college football, and only 1.7% of college players play professionally. And only 0.08% of high school players will move on to the NFL. That's just a little tip for a certain little student who had a certain something to say about high school football and the statistics behind it. So here do you go, certain little student. Here's your facts behind high school football. Now, in other words, let's get to the example now. It says, the cheerleaders at Lake High School launch t-shirts into the crowd every time the Lakers score a touchdown. The height of the t-shirt can be modeled by the function h of x equals negative 16x squared plus 48x plus 6, where h of x represents the height in feet of the t-shirt after x seconds. The first thing I'm going to do is I'm going to realize here that h of x is the same thing as y. Just to keep that in mind, because sometimes we often forget what that actually means. So the first thing it says is graph the function. So remember, as always, as we've done in the past examples, the first thing we're going to do is find the equation of the axis of symmetry. So we're just going to use the formula negative b over 2a to figure out the equation for the axis of symmetry. So using the equation that they gave us, we can see that a is negative 16, b is 48, and c is 6. So plugging those numbers into our equation, we come out with x equals to 3 over 2. So the equation for the axis of symmetry is x equals 3 over 2. And remember, the axis of symmetry is just the x coordinate for the vertex. Don't forget that. The vertex actually tells you, I didn't mean to copy all of that, but the vertex actually tells you what your axis of symmetry is. Okay, so we have an x coordinate. We have our axis of symmetry. Now to find the y coordinate, which would be our maximum or our minimum value. So we're going to plug the x value back into our equation. And once you plug it back into your equation, remember, you can plug this into the calculator exactly how it looks, this entire thing, that it probably won't let me highlight all. Oh, okay, I'm done with the highlighter. You can plug that exactly into your equation, exactly into your calculator, and you will get out the answer 42. So our vertex is the point 3 over 2, comma 42. Oh, I don't know why this highlighter is doing this. So that is our actual vertex. Now, we're going to find another point because remember, we need 3 points to actually make our graph. So to find another point, we're going to choose an x value of 0 and substitute it in. And the reason we're going to use the x value of 0 is because that's going to tell us the y-intercept. Remember, the y-intercept is when x is 0. So if you plug 0 into our equation, everything would cancel out except the 6. So our new point is 0, comma 6. So when we graph all of this onto our actual graph, our vertex happened at 3 over 2, comma 42. So that's where our vertex is. That's that point there. Then we use the point 0, comma 6. That's our y-intercept. And our y-intercept is 6 units over from our axis of symmetry. So our y-intercept is 6x units over from our axis of symmetry. So to find another point, we're going to go 6 units to the right. And that's another point there. So if we connect our vertex to our y-intercept and the other point, we have our parabola. We could also repeat picking points where it says here, repeat this and choose an x value of 1. So yes, we could plug in another x value and we can get out a point. And we could do it that way. But remember, you only need 3 points. So find your vertex, find your y-intercept if you have one, and then find the point that's corresponding to that point, or equal distance from the axis of symmetry. The next part says, at what height was the t-shirt launched? So where did the t-shirt start? So the t-shirt is launched when time is equal to 0, or when x is equal to 0. We've already found that value when x was equal to 0. We've already found that y-intercept. That was at 6. So that means that the t-shirt is launched 6 feet from the ground. Part C says, what is the maximum height of the t-shirt and when was the maximum height reached? We found that point when we found our vertex, because remember, the maximum or the minimum is the y value of the vertex. So going back to our vertex up here, our y value happens at 42. And remember, this parabola is downward, so we have a maximum point. Our maximum height reaches a height of 42. And when did it reach that height? Well, use your vertex. When did we hit 42? We hit 42 at 3/2, which is 1.5 seconds after the launch. All of this information here on this section came straight from our vertex, because our vertex told us what our maximum value was, and it told us when that maximum value occurred. For guided practice, I do want you to do this guided practice section. I want you to copy down this section on a completely separate blank sheet of notebook paper in your spiral. Do not copy this down with any of the other guided practices that you have done. Copy this down on a blank sheet of notebook paper from your spiral. And I want you to copy down the entire example and use the same steps that I just used on this previous example to answer those questions.